Low-level significant weather charts are a vital aid to successful flight planning. For flights that take place between the surface and 10,000 feet. These charts indicate, in a precise and very structured format, the meteorological phenomena which are anticipated in the specified area. In the United Kingdom, the chart is commonly referred to as the form 215, or just 215. It's produced every 6 hours, 365 days a year, for aircraft flying low level over the United Kingdom and adjacent areas. Also shown on the chart is the issue time, duty forecaster, and contact details. The chart is issued approximately 5 hours before the start of the validity period, and each chart is valid for a period of 9 hours. The precise period of validity of the forecast is clearly identified at the top of each chart. In this example, we have a chart which is valid between 1400 Zulu on the 10th of January till 2300 Zulu on the same day. On the left side of the chart is a schematic map. The map is a snapshot at a single forecast time, showing the positions of any fronts, and with different significant weather phenomena clearly divided into areas using black scalloped lines. Any high pressure centres are identified on the map by a small circle, and the letter H, and any low pressure centres will be identified by a small cross, and the letter L. The time at which this forecast map is valid is clearly displayed beneath the title of the chart. In our example, we have a chart map which is valid on the 10th of January at 1800 Zulu. The chart uses standard weather symbols, many of which you may be familiar with. Shown here is a list of codes and symbols. It might be worth spending time looking through the chart and committing some of the symbols and codes to memory. Let's now focus in detail on the map. As previously mentioned, frontal boundaries and areas of weather are clearly displayed. These weather areas are bound by black scalloped lines, and in some cases by the edge of the map area. Areas are clearly identified by a boxed letter. In our example here, we have the map divided up into 6 different areas. Each area is linked to the text contained in the main body of the chart by the area letter. The movement of fronts and area boundaries is identified by arrows, which indicate the direction of movement. The numbers which appear beside the arrows indicate the speed, in knots, at which the feature is moving. If a front or area boundary is stagnant or moving at less than 5 knots, then the word slow appears alongside. Let's now look at the text information on the low-level significant weather chart. As we saw earlier, this forecast information is linked to the different areas on the chart map by area letters. For each area there are 3 different columns of information. The first column describes the surface visibility and weather phenomenon, as well as the frequency and distribution of that weather. The second column contains the forecast cloud and any associated hazard. And finally, the third column details the forecast freezing levels. Let's just focus on Area A, and the first column, which forecasts the surface visibility and weather. The first line of text details the general conditions that are forecast to occur in that particular weather area. In this case, the surface visibility is 30 kilometers with nil weather. However, some variation may exist within Area A which is different from the general conditions. More detail on these variations is provided underneath the general information using abbreviations for widespread, frequent, occasional, isolated, and localized. This will be followed by the visibility, the weather phenomenon, and more precise detail on when or where the phenomenon is occurring, such as the coasts, over land, hills, or mountains. In order to ensure some commonality between the various weather briefing tools, the coding used in the significant weather chart is similar to that used in the METAR and TAF, and shown here is a table to remind you of those codes. Let's decode the surface visibility and weather in Area A. The general condition in Area A is 30 kilometers visibility with nil weather. However, Occasionally, the visibility will be 7 kilometers with moderate showers of rain. In isolated areas in the west, expect 4,000 meters visibility with thunderstorms and moderate hail from 2100 Zulu. Locally, around the mountains, visibility will be down to 800 meters with moderate snow showers. There will generally be moderate turbulence, but widespread severe turbulence to the north. Lastly, in isolated areas, expect hill fog. Hill fog implies a visibility of less than 200 meters, as shown by the information in the legend. The second column of information on the chart relates to the forecast cloud and associated weather hazard. Similarly with the surface visibility and weather, the first line of the cloud forecast is the general cloud condition for the area, with variations detailed in the following lines of text. The first element in the forecast is always the cloud amount expressed as few, scattered, broken, or overcast. Next follows the type of cloud, using the standard cloud abbreviations which are shown here. Following the cloud type is the icing and/or turbulence hazard. The codes for these are shown in the legend to remind you. The next set of cloud information relates to the base of the cloud, expressed in hundreds of feet above mean sea level. And then, followed by a forward slash, are the tops of the cloud expressed in hundreds of feet above mean sea level. At the very end, there may be further information relating to where and when particular clouds and their hazard may occur. Let's now fully decode the cloud information for weather area A. Generally, throughout the area, there will be scattered to broken cumulus and stratocumulus clouds. This will give rise to a risk of moderate icing and moderate turbulence within the cloud. For the icing layer, check the freezing levels for the area. Cloud bases range from 1,500 feet to 3,000 feet above mean sea level, and cloud tops range from 7,000 feet above mean sea level to above the chart level of 10,000 feet above mean sea level. In isolated areas there may be cumulonimbus clouds with bases of 1,500 feet, and tops extending to above the chart level, to the west of the area, any time from 2100 Zulu. You should note especially that when cumulonimbus clouds are indicated, it is implicit that there will be associated severe icing, severe turbulence, and hail. The last column of information in the chart relates to the freezing level. This information is relatively easy to decode and is given in hundreds of feet above sea level. For example, in Area A, the freezing level is forecast to be between 4,000 and 5,000 feet. In Area B, though, the freezing level will be between 6,000 and 9,000 feet, but as low as 3,000 to 5,000 feet to the far northeast of the area. A special weather phenomenon can be seen in the freezing information in Area D. Notice that the main freezing level is at 5,000 feet, but over land there are sub-zero layers of air from the ground to 1,000 feet. At the bottom of the chart is a brief line or two of text, which summarizes the outlook for 12 hours after the expiry of the main chart map at 1800 Zulu. This outlook does not go into precise detail about cloud heights and weather phenomena, but gives an indication of how the synoptic situation is expected to change. There is one additional element which is not shown on the chart, but can be found underneath the chart on the Met Office website. This additional element is a prognosis. The prognosis is a surface pressure chart 6 hours on from the main chart map validity time. In the case of our example map, 6 hours on from 1800 Zulu is midnight. Therefore, the chart time for the prognosis would be 0000 Zulu, as shown. Before this lesson is complete, it will be worthwhile examining a few specific items of the forecast that require further explanation. Occasionally, when conditions suit, an area will be divided into sub-areas. On the map you can see Area B and Sub-Area B1. The reason for two areas to be given similar labels is that the areas share many characteristics, but may have one or two differences. Let's have a look at these characteristics in the forecast information for the area. The general conditions for Area B, and therefore B1, are 15 kilometers visibility with possibly nil weather or light rain. However, widespread throughout the areas, the visibility will reduce to 7 kilometers with moderate rain. In isolated areas, the visibility will be 4,000 meters in heavy rain, but this would mainly be to the far north of Area B, and certainly throughout B1. The next few forecast lines do not apply to Area B1, since Area B1 does not have a warm sector, or mountains, or hills. It's important to understand the next two lines of text. Because there is no qualifier for the frequency, this weather must be assumed to be a general condition for the whole area. Therefore, generally, throughout Area B, mountain waves with a maximum vertical speed of 700 feet per minute at 8,000 feet above mean sea level are forecast. You should generally expect moderate to severe turbulence throughout the area as well. Looking at the cloud section for Area B, notice that there are local areas of nimbostratus, giving severe icing risk to the north of Area B and throughout Area B1. What you've learned during this lesson will provide you with sufficient background knowledge to understand the variety of low-level significant weather charts produced around the world. Even though there are many similarities between most of these charts, there are some differences. However, we hope that the level of understanding of the charts you have now achieved will help you use them in an effective manner. The low-level significant weather charts represent one of the best self-briefing tools for the general aviation pilot, and should form an integral part of any pre-flight weather briefing. The low-level significant weather forecast charts can be obtained from the Met Office website free of charge. For those general aviation pilots flying further afield, there is a chart which encompasses a broader area, and it's called Form 415. An example of this chart is shown on screen. Always ensure you select the appropriate chart to cover the time period you are flying. You can see that several charts are issued each day, and these have different validity times.